let's come to water. Now, in case of water, also hydrogen bonding is involved. Now, hydrogen bonding is involved for orientation of water. Orientation of water when it is in a solid state, that is ice. Orientation of water when it is in liquid state. It's really very interesting. Let's just get into it and unleash the aspect. So let's get into water mode now. Let's understand what are these hydrogen bonds, what are these covalent bonds, and what effect does these weak hydrogen bonds, rather I would say so-called weak hydrogen bonds, play when water is in solid state, that is ice, and when water is in liquid state. Now let's understand why water, in spite of its being sp3 hybridization, the bond angle is just 104 instead of 109 that we saw in case of methane, the bond angle. Alright, now what happens is, now in case of water, the oxygen has two lone pairs there, unshared. Okay, so these lone pairs repel each other, and these lone pairs from both the sides repel the bond pair. So as a result of that, this bond, which should have been like that, or 109 degree, comes to 104 degree owing to repulsion. That is lone pair repulsion, lone pair bond pair repulsion, lone pair bond pair repulsion. But bond pair repulsion is too weak to hold, so the bond angle changes from 109 degree to 104 degree in case of water. Alright.
Hi guys, myself Sudhir. In this part of the video, we are going to discuss about dipole moment in water. So let's go. To understand it properly, first we'll see configuration of oxygen. Oxygen has configuration of 2,6. To understand it further, we'll see electronic model of oxygen. Oxygen has two lone pairs and two shared pairs with hydrogen, and they both are covalent bond. So let's go forward and see the ball and stick model of it. As we all know, oxygen is EWG, rather electron withdrawing group. So it attracts an electron, shared electron of hydrogen, making itself del negative or small negative, and hydrogen positive.
In this part of the video, we are going to see dipole moment. Hi, I am Dhruvi. As you know, oxygen is electron withdrawing atom in water, so it pulls electron pair towards itself, developing negative charge on it, which is small delta negative, and small delta positive, which is generated by hydrogen. As my colleague Vidit explained the same, as you know, which generates the dipole moment, which is mu. Mu is equal to 1.84 debye. Formula for mu is equal to Q into distance, which is equal to coulomb meter. Normally we measure mu into debye. Conversion factor of debye is 1 debye is equal to 3.33564 into 10 raised to minus 30 coulomb meter.
This part again has been already explained by Dhruvi, but just to give you a structural view how it appears. Now I have just put in dipole moment value 1.84 debye, and dipole Y, because this is H, this is H, this is O. O being more electronegative, it pulls the bond pair towards itself, getting small negative charge. And since H are giving out, rather the electron pair is being dragged towards oxygen, so H, both the H's get small positive charge. Now this is what is called as dipolarity. And since there is dipolarity, so dipole moment is there. And dipole moment, it's charge into the distance, it's charge into the distance. Alright, so that unit comes to coulomb meter, cm. And if I put unit over here, it would be coulomb meter, but what we use is debye. So this is the conversion factor. 1 debye is equal to 3.33564 into 10 raised to minus 30 coulomb meter. Let's now get into understanding about these arrangements of water molecule. First of all, let me pick up one water molecule. Now in this case, this is oxygen and these are hydrogen. Now this oxygen, being more electronegative than hydrogen, pulls the electron pair towards itself. As a result, it gets delta negative charge, and here it gets delta positive charge, as already explained by Vidit and Dhruvi. So similarly here also we have delta positive, delta positive, delta positive, delta positive, delta positive, delta positive, delta negative, delta negative, delta negative. So there obviously would be electrostatic attraction between delta negative and delta positive. So this, and since hydrogen is involved, so we call it as hydrogen bond or hydrogen bonding. Whereas here when we see all these are all covalent bond. Why? Because this bond has formed owing to sharing of one electron from here and one electron from here. So it forms covalent bond. Now the energy required to break this bond is 460 kilojoule per mole. Whereas for this hydrogen bond, it just requires 6.3 kilojoule per mole. That itself explains that hydrogen bond is such a weak bond. Alright, now in spite of it being weak, we would see later how it manages water when it is solid water, that is ice, at lower temperatures, and liquid water at higher temperatures. So this is an excellent example where what weak bonds can also do. Alright, let's proceed. Having understood what Vidit and Dhruvi explained, let's move ahead finding what effect does this hydrogen bonding do. Now this is the molecular model of water, liquid water, and this is the molecular model of ice. Now in case of ice, owing to these hydrogen bondings, 6 water molecules are brought closer in this format. Now since it is in this format, so it entraps empty space. It entraps an empty space within itself. Alright. Similarly, and that's all because of hydrogen bonding. Alright. So when we come to liquid water, we find that here also hydrogen bonding brings in 2 molecules of water close by. These are the hydrogen bonding, and liquid water also entraps this empty space. Already have seen that dipole moment of water is 1.84, owing to which there is dipolarity, that is, this is delta negative, this is delta positive, all white which you see have delta positive, all red has delta negative, owing to which delta positive, delta negative attraction, and that is what is hydrogen bonding. All right. Now, and whereas these are sharing, electron sharing, that is covalent bond, and the energy for covalent bond already seen is 460 kilojoule per mole, whereas that for hydrogen bonding is mere 6.3 kilojoule per mole hydrogen bonding, but still it is capable to bring all these 6 water molecules in this format. So it's an entrapping this empty space. All right, now what happens owing to that? Owing to that, the density of ice reduces considerably. Why? Because we know density formula is mass over volume. Now because of this, the volume of ice becomes much more than volume of liquid water. Volume increases, that is denominator increases, so density decreases. Alright, and that's the reason why ice floats on water, because density of ice owing to this empty space entrapped is much lesser than that of water. Alright, now in another interesting thing in case of water. Now suppose water you have consumed is 300 ml, but now you know it won't be 300 ml because you have got to subtract this empty space from that 300 ml that you have consumed. Alright, so there will be so many such molecules, so that all those volumes have to be subtracted from the total quantity or total volume of water that you have consumed. Alright, so that again is owing to what? Again owing to weak hydrogen bonding. Alright, I hope you enjoyed this video on so-called weak hydrogen bonding. Still there are lots that I intend to speak. I'll pick it up in my next video. Alright, that would be about isosorbide and some other thing. Isosorbide is again a product of glucose. All right, that would be very interesting. Please wait for it. All right, see you then.